Hello, and welcome to the eTech podcast with me, your host, Ryan Morn. I have been involved in the development of electrified vehicles and machines since 2005 as an engineer and a business leader. This podcast is the product of my passion for electric and autonomous vehicle technology. I'm here to share knowledge from some of the world's leading experts, as well as my own insights. Join me as we accelerate the transition to cleaner, safer and smarter vehicles and grow the industry around the world. So I'm super excited today. We've got a long-time friend, someone I've known for many, many years, Professor in Electrical Machines and Power Electronics, Volker Pickett, in to talk about his work and the interesting research that they're doing at Newcastle University and various challenges facing electric vehicle manufacturers. And Volker's been involved in vehicle electrification for longer than I have, many, many years. Really interesting guy. So we spent quite a lot of time talking, and I really hope you find today's episode interesting. Okay, so we're here with Volker Pickett, who's the Professor of Power Electronics and the head of the Electrical Power Group at Newcastle University. So Volker, do you want to just tell us how you got here, a bit about yourself?
Yeah, no problem. Well, thank you, Ryan. So as I said, I'm Professor of Power Electronics at Newcastle University, and I'm at Newcastle University since 2003.
Wow.
Now, originally I'm German. I was born in a town called Wolfsburg. And for those who don't know where Wolfsburg is in the north of Germany between Berlin and Hanover. And it has a population of 180,000 people, and 55,000 people are working for one factory. And the name of the factory is Volkswagen, so VW. So you need to imagine 55,000 people going into work and 55,000 people going out of work every day.
Wow.
So that means effectively every second person works for the factory, and the other second or the other half are working then for the supply chain. Right. So you grow up in an environment where your destiny is already written on your forehead, and that means it has to be to do something with cars. And I choose to work on electric and hybrid electric cars. And that's what I did now for the last 25 years. I have industrial experience. So I worked for Volkswagen. I worked also for another company in Nuremberg. And then I decided to do an academic career. And since 2003 now I'm at Newcastle University and became then professor, and then also the head of the group, the Electrical Power Group, which is a large group, by the way. It counts now nearly up to 100 researchers.
Wow.
I'm quite proud, obviously, of leading this group.
And what kind of work do you do in that Electrical Power Group?
Okay, so the group itself is, let's say, subdivided in 4 subgroups. One is power electronics, the other subgroup is electric machines, the third one is electric drives and control, and the fourth one is called power systems. And the group, what I like on the group is we have an equal balance of people within each of the subgroups. Meaning there's an equal number of PhD students, an equal number of academics, but also an equal number of postdocs. Having them all under one umbrella allows us obviously to do cross-disciplinary activity. So effectively knowledge is transferred between these 4 main groups, which is very beneficial for our projects.
And it's such an interrelated. You can't really do electrical machines now without doing power electronics. The two are so
that's right.
Intrinsically linked to each other.
Yeah, that's right. You need to have a good conversation with those who understand the other half, and you need to merge them together. And although we have these subgroups, but then we are building teams which are then working on individual projects. And that works quite well. So also it is quite exciting for the postdocs and RAs because they work effectively on different projects. Yeah. And that is quite helpful for them to build more knowledge, but also for their future career to find a job.
Wow. So I often say to people that we started Avid before electrification was fashionable.
Right.
But that's only 14 years ago. So
Okay.
you started doing vehicle electrification 25 plus years ago. Wow.
Yeah.
So 25 years ago, Volkswagen was working on electric cars.
That's right.
Wow.
So one of the first cars that I drove at Volkswagen, it was a Golf, and that was powered by lead acid battery, and the power drivetrain was 18 kilowatts.
Wow.
So if you argue, what is the acceleration from 0 to 60 miles per hour, the answer is nil, because I never made it. But a fundamental change was then, or a fundamental decision was then made, and it was argued that obviously the power was too little for any type of car.
Yeah.
So effectively, then they boosted up the power level. So we went then to 50, 75 kilowatts, and then later even 250 kilowatts.
Wow.
And we were also one of the first who used lithium-ion batteries. So there was the period of obviously lead acid. Then we looked into nickel metal hydride. But then we were one of the first one, when I say we at Volkswagen, we were one of the first one which used then a lithium-ion battery.
Oh,
so we were quite proud of it. And that was a 150 kilowatt power drivetrain.
Because they're kind of, rightly or wrongly, because of various things to do with diesel engines, Volkswagen are kind of not necessarily seen as being the leader in electrification right now. Correct. But clearly that it's been on the corporate radar there for a long time.
Yes, that's right. So when I worked at Volkswagen, the division that I worked for existed basically in order to monitor the technology. We built obviously various prototypes, but also fleets. Yeah. And we existed just because in case legislation is changing, so that we are ready for it. Yeah. But you're right. I mean, obviously Volkswagen is selling diesel cars. Yeah. That is where the money is. Yeah. But we all know there has been now a change. Not even at Volkswagen. Effectively, all OEMs are thinking now, obviously, in making green machines. We assume, or we hope that they are green. So that means they make now electric cars. And going back, obviously, to Volkswagen now, as you know, that Volkswagen will have by 6 or 7 years, I think, 25 different electric cars. Yeah. And also quite interesting to see is that most car manufacturers think about the platform approach. Yeah. And as you perhaps know, with the combustion engine powered car, you have effectively one platform and have different engines. Yeah. But then you have different what we call HUDs. So let's say a Golf has then also it's like from the scooter point of view, if I can say this here, right? Yeah. So that happens now on the electrification as well. So you have effectively a chassis with specific type of batteries, with a specific type of power drivetrain, which you can manipulate slightly. But then you get a high variation of different cars.
So this is the MEB platform that Volkswagen are shouting about.
That's what they are discussing, yes.
Yeah, it's been interesting to see. And I go personally, I think that the dedicated EV platform is the right kind of approach, because there always seems to be too many compromises when you do a conversion. You don't end up with a very good solution. But it's going to be really interesting to see those products. If they're half as good as some of the PR and marketing of the products that are coming on the MEB platform, I think it's going to do really, really well. Be really exciting to see that over the next couple of years. Yeah,
I think so too. I mean, we'll see a radical change. We know that effectively all OEMs are having already electric cars on the market. Yeah. And I think where the biggest where we see the biggest improvement is in cost and in range. We shall not forget about this. I mean, going back, 6-7 years ago, the battery cost was effectively half of the cost of the car. And I mean, the cost of the battery has dropped. And there are some kind of research work and also some kind of reports which predict that in 10 years the car of an electric car will be equal, or the price of the electric car will be equal to a combustion powered car, apparently. But it definitely goes down. And also we shall not forget that the range is going up. So, going back, we had now, 24 kilowatt hours on battery storage. Now it's on the 40. In the future might be 66 kilowatt hours. Yeah. So this is all beneficial.
it makes the product do what people want.
Yes.
And I guess, so coming from that very heavy automotive background, you're, I guess a lot of what you do now at Newcastle, or have done in the last few years at Newcastle University, has been very automotive related, or do you get involved? Because Newcastle work on some really big programs, don't they? You've got...
That's right. I mean, our group itself works on European funded projects, on projects which are funded by the British government and also from industry. I think what makes us unique is that although we're an academic research group, 60% of our funding comes from industry directly. Right. So we are not so much depending from funding from the government as such. Right. And we work heavily on the transport sector. And transport obviously includes the automotive, which is the biggest activity that we have, but it's also in the aerospace sector. Right. But then we work also. We have also a few projects in the marine applications and the railway too. In fact, we just submitted a proposal for a call for railway application. So the good thing, obviously, working in these different fields of transport is that how can I say? Sometimes the questions are all similar, but also sometimes the technology that they use in one area or the other one, you can merge them together, or you can try to apply them, for these different sectors, which is quite exciting. And it's interesting that sometimes if industry visits us, is not aware of it, of this. I do believe that one need to do more work, perhaps in the future, to bring industry from these different sectors together, so that they start to communicate with each other.
Maybe in electrification, that kind of crossover is probably more than it has been in the past, when there's been very different requirements for engines and power sources.
That's
and
right.
Things
Yes.
like that.
Yeah. I mean, there's definitely more going on. You're right, Ryan. And I think one of in particular, the activity in the aerospace sector and the automotive sector seems to slightly merge together, and that is just because of the announcement from Siemens and Airbus, to build now the first 100-seater hybrid electric plane. As we know, there are already electric planes out there, but they are 2-seater types.
Yeah, tiny.
I mean, the focus here, when we talk about hybridization of a plane, is slightly different than the hybridization of a car. Okay. So in a hybrid of a car, it's more tailored for the city center. So acceleration, deacceleration, you recuperate energy, and so therefore it becomes more efficient. But from the plane point of view, you still need obviously your jet propulsion. But the approaches here, you use many small electric motors, which you're using also for propulsion and for generation, and that means that the whole structure of the plane can be completely reshaped, and that means the aerodynamic becomes now much better, and that means you have fuel efficiency. So the approach is slightly different, but nevertheless, in the end, obviously they also ask for high power density, low cost. Sometimes even their specification in the aerospace sector, you could argue, slightly more harsh. But you're right. I mean, there is more and more cross-referencing now between these two sectors.
So do you think electrification, because actually, we talk about electric vehicles all the time, cars and trucks and buses, and that's really, people see them now on the road. And you and I were working on them 10 plus, well, in your case, 25 years ago.
Yes, that's right.
Sorry, I won't remind you of that again.
Thank you.
But no, we've been working on them for a long time, but now everyone gets it. So I was saying to someone the other day, just 3-4 years ago, you talked about an electric car and no one got it. People were like, milk floats, or these sort of really bad examples kept coming. But even though there was some great stuff being worked on to come, it wasn't, Tesla wasn't a common sight on the road, and the big OEMs hadn't fully shifted over. But now, with cars, people get it. The new one, which seems to be gathering pace quite quickly at a technology side, but you don't see anything really out there yet, is aerospace. Mm-hmm. Do you feel like that's going to come through quite quickly with hybridization in aircraft, or do you think it'll be a long, slow process? How do you think it's going to go?
I think it may go slightly quicker than what we experience on the electric car side.
Okay.
Because we shall not forget, the electric car is, it's quite old invention. It goes back to, I think, 1832. There was a Scotsman. He came off the idea to put an electric motor in a car, in a carriage. It wasn't a car at this time.
Yeah.
He didn't put a battery in, by the way, so it was driven by a cable. But then, if you go through the history of cars, and in the 1900s, as you may know, is there were more electric cars in the US than petrol-powered cars.
Yeah.
And then obviously it died down again. And then in the 60s and 70s, where we had the smoke and then also the oil crisis, there were a good number of electric cars in California driven by the Californian Air Resources Board.
Yeah.
So it has a long history. In the aerospace, I would say it may accelerate slightly quicker. Because first of all, they obviously learned from the past what the electric car went through.
Yeah.
But I think there's more now the need for the electrification. And also bear in mind, there are not as many manufacturers, plane manufacturers.
Yeah.
So effectively, if they decide we want to do this, then I think they will move forward.
And is it a legislation thing? Is it to do with CO2, or is it saving money on fuel? Or
I think it is, as far as I understood, is that it's driven basically by Airbus, and I'm pretty sure that the Americans or Boeing will do the same. One of the reasons is that in China, there's the first manufacturer who will now build commercial planes.
Okay.
And so they believe that they perhaps will undercut the price.
Yeah.
So therefore you need to answer with new technology. And if you now develop a plane which is obviously much, much more fuel efficient, so there is a way to sell or to keep in business. So that is one of the driving force.
Mm. No, that's interesting. So maybe the threat of a bit of Chinese competition is driving some innovation.
Yes.
That's interesting.
Yes.
So you're clearly at Newcastle. Then you're doing a lot of work on really high power density, high performance motors and drives and that kind of thing.
Yes.
Do you feel like do you have a kind of particular specialist pet topic, or like you used to be the guys for segmented stators?
Yeah.
That was a real thing Newcastle was
So
always famous for.
It has been a while ago.
Yeah.
we moved on.
Yeah. What are your kind of big tech areas?
Well, I mean, bear in mind, obviously, it is a large group. And first of all, as 60% of our funding comes from industry, we see ourselves as a partner for industry to work with them together. And every industrial partner, as you know, has different problems, and we try to solve with them problems. So the requests varies. Yes, we do obviously research. And in terms of, let's say, trends, so if I bring it into the context of the electrification, then one aspect is, for instance, the wireless charging.
Okay.
So as we all know, the biggest problem, I think, for the electrification is, you need to have obviously the power available to charge your electric car.
Yeah.
And as we know, at the moment we live in the world where we have 7 kilowatts, 50 kilowatts, and a little bit above 110.
Yeah.
But as the energy density of the battery goes up, we need obviously more power. And in Europe, they built now this 350 kilowatt charger, and there is even the demand of 500 kilowatt charging point.
Wow.
And that is a half megawatt. Yeah,
that's a big cable.
It's a big cable. I'm not sure if the individual will still, plug it in, or if it's then an automated robot system.
Yeah.
So the bottom line is, however, we need to obviously transfer the power, to these individual charging stations, and the whole infrastructure, needs to be looked at. That is what we do as well.
Yeah.
But also, it is not even building, putting cables in. It's also, balancing then the power.
Yes.
If you think about you're on a highway and then you go on the petrol station, or the highway petrol stations, how many pumps do you have? 20 perhaps, right, on one side. So now convert them in 20 500 kilowatt charging points. that is a lot of power. And when they all demand at the same time this kind of power, then you need to balance the grid. And there are quite a lot of hurdles to take. So that is one aspect that we do. But going back to the wireless one answer could be, for instance, the wireless charging, what we call the dynamic road charging.
Okay.
So you put effectively coils in the road, you have a coil in the car, and then continuously you charge the electric car.
All right.
So that is one aspect.
Does that work?
Well, it works, yes. You just need to go to South Korea. KAIST, for instance, they have buses running on this principle, and there are other prototypes which are operating. Yeah. There are obviously challenges. The biggest challenge is the electromagnetic interference that you produce, and that limits you in terms of the power that you can transfer. There are other challenges too, but perhaps the biggest non-technical one is the cost. Right. I think having this type of highway system, for instance, will bring you easily, I would say, maybe 5-6 million pounds per mile of one highway stretch, which is quite a lot.
Significant, yeah.
But there is also, and that is another project that we work on, another alternative, and we call it a trucked electric vehicle one. Right. So where you have effectively conductive dynamic road charging. So it's going slightly back to the railway industry. Yeah. So there are publications out which you can read. So Siemens and Volvo and even Honda working on these systems where you pick up the power, where you have effectively in the road like a metal stripe, let's call it, right? And then you have a shoe which glides over the metal stripe. Obviously, it's energized. And this way you can put quite a lot of power through. I think Honda in the latest publication claimed 450 kilowatts with 200 kilometers per hour.
Basically a big scale electrics car.
Yes, you can say it on a very large scale, but obviously it has its own challenges. But this is an alternative to wireless charging because it's cheaper. And you can use quite a lot of synergies from the railway industry. Right. So there's a benefit in it. Right.
So pretty huge areas in themselves, and on electrical machines, you have lots of people actually doing work on e-machine design.
That's right. Okay, so on the electric drives, first of all, there's obviously the move from the converter point of view to replace silicon with silicon carbide and maybe GaN devices. Yeah. So we have work in this area. We also work in wheel motors, for instance. The principles of the classical machines, they are all there, like switch reluctance machine and PSM machine, synchronous machines and transversal flux machine. Yeah. So we're always looking for obviously new materials, new machine design. There is no radical new type of machine out there. But it's always an improvement, and it's amazing how much you can do. If from an outsider, a motor always looks round, and you can always ask yourself, what more can you improve? You deal with copper and then laminations and some magnets. Magnets is obviously a hot topic. As we know, the neodymium, 97% of the neodymium is held in China, and so therefore China can dictate the price. And our goal is obviously to make machines without these magnets in order to get the same power density that you normally achieve with neodymium-powered motors.
So it's like going into kind of switch reluctance or using kind of ferrite-based?
Ferrite-based, we look into this, obviously switch reluctance too. Then the classical, synchronous machine. And, there are some OEMs, may go back to the induction machine. It builds slightly bigger, obviously. Yeah. But then you may get other benefits, as we all know that the French manufacturer, they used also the electric motor as a charger for the car, for static charging, because you use the electric motor as a transformer then. Right. Yeah. So basically one aspect which is, I would not say novel, but which becomes more and more popular is what we call multifunctionality.
Yeah.
So as you know, we have the electric power drivetrain, and at the moment it's just to use to spin the wheels and to recuperate energy. But you can also use now this drivetrain to charge the battery when your car is static, right? So that means you would save a complete charging unit in the car. And you can play this game in all directions with other electronics and machines that you have in a car.
Right.
So that means you give a unit more functions without obviously redesigning completely the unit. And there is quite a lot of savings to make.
I guess that makes sense, because a battery charger is basically an AC to DC converter, and a traction motor inverter is effectively a DC to AC converter. So
you can go even further. The battery management system itself is power electronics, so you could also use a battery management system as a charging unit.
Yeah.
So you charge the battery management system becomes a charger on its own, so you don't need again a separate charger.
I did see the Tesla Model 3. They've got this lovely. I think they call it penthouse on the back of the battery pack, which has the DC converter and the battery charger built in, but it's very, very integrated into the battery pack. Then the Renault Chameleon's fascinated me for a long time, and I think they've got some really interesting IP around that. But it's I don't know if other people will be able to come up with similar things without treading on that IP, but that kind of use of the traction inverter as a charger. Seems to, there's some compromises, but actually there's a big saving there in terms of getting rid of a very expensive component.
Exactly, yes.
I didn't realise that was reliant on having an induction motor. So
not necessarily. I mean, you can use it to different motor types. You can use it for obviously a switch reluctance mode machine, which might be more beneficial to some degree. But then it's a pros and cons with every concept, as you know.
Right, yeah.
So all I'm saying is we are still obviously continuing to look into new cooling systems, for instance, and then high integration. So to get the power electronics as integrated as possible in the space of the electric motor by sharing the cooling, for instance. And so that is work that we do. What we shall also not forget is, and that goes slightly again to the smart grid, which I mentioned earlier, which we would need in order to distribute all the power. That is what we call vehicle-to-grid charging.
Yeah.
So that effectively the batteries of the car stabilize the grid. Now this is a quite interesting research topic too, and in fact in the UK there has been several projects now launched, some in Newcastle but also in Birmingham, where they look into the technology, but also obviously in the user behavior, because it might mean if you charge your car, you always think obviously the battery is now full, but when you come, it's just maybe only half full or 60%. And it opens up so many other opportunities. For instance, if vehicle to grid would come, then you effectively, as a owner of the car, sell energy to the grid provider. So you become effectively a business person and set the price by when you want to sell the energy. Interesting.
The grid reinforcement and things like, a lot of companies at the moment have uninterruptible power supplies on site, and I've seen people doing business models where they're, one level is, in the past we used to own our UPSs, now we're not going to, someone else will own them and operate them, but then basically they run that as a business that sometimes it's a UPS and sometimes it's providing grid support. But then I've seen so the next level is, we don't even have a physical UPS. We have the ability to kind of call on spare capacity in local electric vehicles. It's quite like, the possibilities are not quite endless, but there's so, must be quite hard sometimes to almost pick a particular area to really drill down and focus on. Is that something that you have to do, or are you sort of led by your industrial?
Well, mostly the industrial partner knows what they want. Right, and then obviously we try to guide them and come up with a solution, a way forward. So it's quite rarely when the company says, do whatever you want, and mostly they have a problem or a challenge, or they want us to look into a specific direction. We advise them, obviously, with our experience, sometimes maybe not to go this direction,
Right.
rather than putting the money on the table and then we say we think it's not the right step forward.
Right.
Yeah.
So given where things are at the minute with electrification of everything, so we talk about aircraft and cars, and there's robotics, and your group must be in really big demand. Is it growing in terms of the number of researchers, or is that?
Well, it is for sure. When I became head of group, we were not 100 people, that's for sure. And we are quite successful in, attracting money, if you like. So recently, with Sheffield University, we got the manufacturing hub, which is looking into machine design, manufacturing, and also looking into the aspect how do you need to design the motor so that you can save money on the manufacturing end, for instance, right? Then just hot from the press, if you like, it was last week on Monday, the government announced the new doctoral training centers in the UK. And I'm pleased that my group received a doctoral training center in power electronics for sustainable electric propulsion.
Okay,
only for electric cars and the aerospace industry.
Oh, wow.
So with 20 industrial partners, we are now training new leaders in the field of power electronics and electric drives. And our training program is quite unique, and I think that is the reason why it has been selected.
Yeah.
And that is that we do not only want to provide, obviously, in-depth knowledge like the classical modules that you normally teach, like power electronics machines. But there's more to it. So they will learn, for instance, about manufacturing. They will learn about materials. Yeah. They will also learn about business and how to set up a company, for instance. Right. And they will also have, at the beginning, quite a lot of practical training units. Yeah. And after the first year, then they will spend the remaining 3 years with the industrial partner to do the thesis research. Okay. And we're looking forward basically to ramp up the numbers of students. So the minimum what we expect is 50, but I do think over the next 8.5 years we will certainly have 80 or 90. And
they'll be all working towards a PhD?
They will all work towards a PhD, correct,
wow.
Yes.
And that's quite... like 50 people doing a PhD in power electronics specifically for automotive. I mean, that's massive.
You say it's massive, but bear in mind the statistics are slightly different because there's a shortage on skills in power, as you perhaps know as well. I mean, everybody is trying to get hold of experts. And therefore, I think the number is relatively small. And, don't forget, obviously, 50 people. I mean, how many companies do we have who make electric cars here and who, work in the tier 1 and tier 2, obviously you as well. And so therefore, the number is relatively small. So therefore, I do hope that we will ramp it up more and more. Yeah. And important also is for us that we'll become completely sustainable so that not the government in the end pumps money into it. Yeah. So we want that industry all together basically sponsors these students. And we have fantastic networks already enrolled for our CDT, like, for instance, the Power Electronics UK, also Innovate UK, the IET even supports us.
Wow. Yeah, I think there might have been like one person doing a PhD in, vehicle electrification stuff, 15 years ago. There's 50s. I guess the problem, me getting all optimistic, but the problem is thousands of engineers and professionals not, so it's kind of like a good step, but it's a small step and then a lot more needs to come.
It is. And I mean, overall, I think the numbers of engineers, is constant. Obviously, we would like to have more engineers in this country, right? Because there's always a higher demand and higher need. And obviously, in particular, we would like to see more women in this discipline too. Yeah. So this CDT is certainly set up that that your background in order to be on the CDT on this one is not necessarily that you have an electrical engineering degree.
Okay.
So we have what we call a cohort training based approach. So we deliberately want someone with electrical background, someone with mechanical, material, big data, a scientist. So we bring together people from different backgrounds, and I think that is a very good way forward, how you learn from each other, and you learn these different disciplines from each other, which is much more effective than me as a lecturer teaching someone. So that is one approach, and I do hope that this is quite exciting for the young generation, and we are just now in the process of setting it up, so by the 1st of April it should become live. And then from there we will target obviously the individual students who are interested, but also industry, and we will make ourselves much more seen and our voice much more heard. But it is necessary for the UK to have this centre.
That's fascinating. That I missed that, to be honest. I thought it was all about the sort of electronics engineers, basically electrical, but big data, all sorts of different. Which of course you need, particularly with the way things are going, with things like AI and machine learning, and self-driving, and these things all end up converging. Even sort of human behaviours and psychologists and stuff.
That's right. But you're right. I mean, you mentioned earlier, you have experts on machines and power converters, so they already need to communicate. So in order to communicate effectively, you need to have a little bit an understanding of the other subject, and exactly that is what we provide. So you get a very broad. On one hand, obviously a very detailed one in terms of you still learn the classical subject, but then you get a very broader contents as well. And then you have the cohort, so these people with all these different disciplines. So I think it's quite exciting. Well, I'm looking forward, obviously, to run it. And,
that sounds great.
Yes.
And you still get, I was going to say get your hands dirty, but that's probably not fair to the undergraduates. You do undergraduate. As well. So part of you in amongst all, do you find time for teaching?
We do. I mean, and obviously with the undergraduates, it's always slightly sometimes a little bit of competition with the mechanical engineering. It seems to be like coming in waves. So if mechanical is up, electrical is down, and then electrical is up and mechanical is down. So I never understood why. I think overall, I personally would like to see more people doing engineering, and I think we as a society should basically advertise engineering as something which is good. And one challenge I think here in the country is the word "the engineer." As you know, basically everybody can call themselves an engineer. I think there's something what we need to change somehow. We need to say how exciting actually engineering is and could be, and also, as I said, it's not only for the male people. Women are equally good and sometimes even much better. And we need to address the whole aspect of bringing women more into STEM. And I think it needs to start on the school level already. And it's our responsibility, so industry, but also us at the university, to go to school and basically promote more engineering.
Is it a challenge? Because I see that the courses have grown, and I know that. So when I went to university, basically to do engineering, they were so desperate for people to go and study engineering. You could almost fail your exams, and they'd let you in. So it was kind of. It's very different then, but now it's actually the entry requirements are way up. I know there's a couple of the courses I'm involved in, they're very demanding now in terms of the entry requirements to get onto an engineering course. Your course at Newcastle's grown quite a bit, but then I do hear some universities say basically they can't afford to grow their engineering courses because it's so expensive to teach compared to something like business. And the way the funding works and things, is actually there a challenge there in terms of growing the supply of teaching?
It is. I think you need to be flexible. Our university or our faculty has just seen a restructuring process to address this. The restructuring process is in a way that historically we had up to 10 schools. and they have been, or some of them have been merged to one larger school. And one aspect is to obviously, on one hand, run the university more efficient, but also to provide now a bigger pool of academics who then can teach different subjects, but also provide new subjects too, which are important for the students. I think the university itself need to adapt, obviously, to the, in order to increase, you need to adapt, and you need to come up with new lecture methods, with new way of even how you assess students, but also you need to be more fresh in order to bring students from different disciplines together. I think that is the best way forward.
It's difficult, I guess. And the other sort of challenge is then as you scale up, so that we need more engineers, but then you can't sort of dilute the quality by scaling it up. And I've got to say, in the past, so when you and I became engineers, maybe a little bit differently in the UK to Germany, but you had to really want to do it, because it was, like literally in primary school you would be getting picked on because you were interested in science and maths, Whereas now it's quite cool, the kids are, my kids certainly, they're very proud of science, and the school makes a big fuss about all that sort of stuff. It's really changed, but then you've got people doing it. So if you wind back sort of 20 years, you had to really, really, really want to do it. Whereas now it's something that, there's a wider group being drawn into it. You wonder if that's going to dilute the
Maybe, I think sometimes, but that's my personal opinion, I may be completely wrong here. I think it has something to do with the fees.
Right.
Because once, obviously, the government increased the fees, there were quite a lot of students who effectively want to go into different directions, with nothing to do with engineering.
Yes.
But then maybe with the degree what they get out of it, they may not get any job.
Yeah.
So consequently, then they decided, okay, I do a degree in engineering, then I get at least a job.
Yeah.
But the bottom line is their heart is not in it.
Right.
They may, the worst case scenario is they may not make it. Right, because they see suddenly, well, it's not for me, really. Yeah. And then they drop out, and that is obviously not what nobody wants. But then in the end, what we also don't want is that we have engineers who just became engineers because of the fees and because they think they get a better job opportunity afterwards, which is true. But the bottom line is we really want passionate people. And in order to make it passionate, it's not only the responsibility of the student, but it's also the responsibility of us.
Yes.
We need to explain basically in much more not more detail, but maybe in a different way, how good is engineering and what can you achieve, and it's so versatile, and you can go abroad and you can travel if you want, and also you can effectively work obviously in different disciplines afterwards, because quite often mostly students think, well, once you're finished you work in research or development, but it's not true, isn't it? I mean, there's so many other stuff. You go in technical sales, in the manufacturing, and in other sectors, in the service sector. That's all where we need engineers.
As long as you don't do what some people do, some of my friends even have done, where they studied for engineering and then they became accountant.
Oh, well,
because actually, you make a good point about the engineering as a degree. Actually, you can. It's a very good sort of multi-purpose degree, and the big accountancy firms and law firms and investment banks and things actually seek to recruit engineers. Because basically they're numerically literate, and you can drive a spreadsheet.
Yes, that's right.
You get stolen to go to the dark side.
That's right. Yeah.
Maybe. The people whose heart's in it. Maybe we need to make sure they do go that way.
I mean, the main reason is also. I mean, we should not forget. I mean, I guess perhaps another reason why they went there is because the salaries might be slightly higher than in engineering. But that is something which needs to be looked at in this country too. I think sometimes engineers need to be slightly higher valued in terms, obviously, of their salary. I understand, for every company it's difficult. Yeah. But it is quite clear if the salary would be higher, then you automatically attract also more people. Yeah. But the bottom line is whatever the salary is, I think you should only do the job that you really like.
Yeah.
Because that is what counts most.
Yeah, definitely. You spend such a big amount of your life at work.
Yeah, exactly.
Why do a job?
25 years, you see.
Do you get? Is there anything coming on your side on degree apprenticeships?
Yes, we do run already the degree apprenticeship.
Okay,
yes.
right.
So that is running since last year, so it's relatively new.
Okay.
And I mean, again, obviously quite exciting times. I mean, we need to learn also how it works effectively or efficiently. But yeah, it's running now, and we're looking forward, to obviously go through the cohort or go with this cohort together through the system. Yeah.
So just for anyone who's not in the UK or who is in the UK who doesn't know what a degree apprenticeship is, because it's quite mind-numbingly complicated. Unnecessarily. What the government did a few years ago was they took basically really trying to push these things called degree apprenticeships. So that's an apprenticeship like you would normally have, where you're based with a company, but then the idea is it goes right through to degree level. And they've actually, it always strikes me as being a little bit strange that there's a lot of fees and there's sort of complication applied to being a normal undergraduate and studying a degree, but they've actually put a lot of funding into these degree apprenticeships. So it's almost like they're trying to sort of encourage people to go that route rather than just do a regular undergraduate degree. And you get a lot of the same benefits, and instead of basically, if you're a young student and you're looking at the two opportunities, you can go and pay quite a lot of money to be an undergraduate and have the undergraduate life, or you can be paid normally to do a degree apprenticeship. It takes a little bit longer than the regular route, and it's probably harder work, I think, for the individual, because you are working and studying and stuff all at the same time, so it is like a full-time job and then some.
But you get used to it.
Yeah, and you get paid.
Yeah,
you don't come out with £50,000.
That's right. That's right.
You come out and you've probably already started to buy your first car and maybe have a nice apartment somewhere or something. So it's quite a big difference. And the one of the challenges has been, though, there's all this funding came about, and everyone got really enthusiastic about it, but then nothing really happened in terms of. That's right. Yeah. So it's. I didn't know.
No. I mean, it also takes a little bit of time to set it up. In fairness. But yeah, I think much more needs to be done. More themes like this one should be basically offered.
Yeah.
And maybe there are any kind of hybrid combinations that you can think about it. And I'm pretty sure they will come. But at the moment, so we are learning with it as well, and we are quite excited, and let's see how it goes.
Yeah. Okay. Cool. So basically, just checking the time, we wrap up now. But what's getting you most excited about this next couple of years in electrification, and what's going on at the minute? What are you most excited about?
To be honest, everything. No, I think it's. I mean, obviously, it's amazing to see. When I drove basically an 18 kilowatt powered Golf, and now you have the Formula E and supercars, which are electric. I mean, to see the transition that is exciting, and think about it now. The next 25 years. Hopefully I will still be here, but for the next 25 years, if we would see the same transition again, it would be, how would these cars look like? And it's I mean, it's very exciting. So I cannot actually pinpoint any kind of technology. For me, it's always the whole package. I can get excited about quite a lot of things. Yeah. And I mean, I'm just looking forward, what the future brings, how electric it will be, and hopefully it will be fully electric by then. Yeah. And I do know there are so many hurdles still to take, and that's the challenge that I like to take on with my group. And
what do you think the biggest challenge is, or biggest hurdle? What's the biggie? I
mean, I think the biggie for me, I would argue, is it is the grid.
Right. Yeah. Okay.
So you need to have, I mean, you can have obviously these electric cars everywhere, but you need to charge them. You need to stabilize the grid. We need to think about somehow, who's paying for it and how do we stabilize it. And bear in mind, we shall not forget, obviously, the cars are only green so long they are powered by wind power and solar power and nuclear, although some people argue it's not the case. But, so long we still have obviously coal station and gas station, which contribute to the electric mix, then we need to be careful, in terms of emissions.
Absolutely. It's a massive challenge to get right. So keep you and I busy for another 25 years, I would think.
Yes. So maybe in 25 years we sit here together.
Again, I hope so.
I hope so too.
Okay. Oh, brilliant. Oh, thank you. Thanks, Volker. That's been really good fun. Thanks very much for coming in and talking to us.
Okay, thanks for inviting me. Thank you.
So I hope you enjoyed today's podcast. As ever, please leave us a comment, hit like and a rating. It really helps the show reach more people. If you've got any specific questions that you'd like us to answer or any topics that you think would make interesting future podcasts, then also please feel free to drop us a line. That really helps. We've got some really exciting new shows coming. So as ever, thanks for taking the time to listen, and I look forward to speaking to you soon.